Hello, everyone, and welcome. Let's go ahead and get started. Welcome, everybody, to Postgres Conference. My name is Zach Tedder, and I am a command prompt DBA. I've been here for 3 years. And before I was a DBA, I was a counselor. So that's a little bit of my background. I've been here for 3 years, working with Postgres, learning, growing. And so my presentation today is hopefully to help solidify some of my knowledge that I've built up in this time, as well as, of course, spread the knowledge to you all. And while we're going through this journey through Postgres, while we're exploring the elephant, I'm going to be providing some slides that will help outline the topics that we're discussing and associate that with presentations that are happening here at Postgres Conference. So that being said, I'm curious, before we get rolling, how many people in here are DBAs? Okay, cool. And how many of you actually work in Postgres right now? Okay, cool. So got a good assortment of people, so this is very applicable to everyone. Fantastic. All right, so this is what, whenever I said about this journey, this is what I thought I was creating. I thought I was going to take all these puzzle pieces, all these aspects of Postgres, and I was going to put them together in this nice little puzzle. We were going to construct it, and I was just going to give it to you, and here it is, right? We hit the easy button, all done. Well, this is actually what I have for you, okay? I got a bunch of the puzzle pieces together. I hope it's all of them. I don't know. Probably not. But I got a pile of puzzle pieces, and hopefully what we can do is we can walk away with this framework, right? So a nice little understanding of something to start with to really get the puzzle going, okay? So we'll talk a little bit about why Postgres. I'm sure most of you already know why. So a lot of these slides we're going to go through rather quickly, since it's a very high level, and most of you obviously have a good, firm understanding. We'll go through why Postgres, then we'll go through objects and aspects at the global level, then the database level, schema level, table level, and then we'll go into some internal process and some disk structure stuff. And then I'll break through each section for questions, okay? So if you have those, please let me know. And again, the resources we're going to be doing throughout the presentation. So why Postgres? Of course, because it's open source, right? Not only is it free to us, but it's actively being developed. It's ACID compliant. Make sure all your data is very secure and has much integrity. It's got tons of advanced features, not to mention customizability, right? Advanced indexing for full text search. We have JSON support. It's cross-platform. Again, it's incredibly customizable at many different levels. The performance for Postgres is great, as well as the scalability and many good security features, which I won't be going over much of those, but they are there. So having said that, if you're not on Postgres and you are interested, I do believe that these presentations will give a lot of helpful information on how to get over to Postgres. So again, we got that one, Michael, for you today at 2 for Postgres for Oracle DBAs, right? So there should be something here for everybody, hopefully. So if you want to take a picture, go ahead. If not, I'll go ahead and move on. Yeah. You're good.
That lady I mentioned before, she and I were talking, she said that apparently Postgres is the most tolerable for Oracle conversions, at least from Azure. So she used to work at Microsoft, and her job essentially was to bring in Oracle customers to Azure and to host it there.
Gotcha.
Postgres she said, was the best kind of staging area. So that's one of the things she suggested.
Delightful. Okay. Very cool. All right, so we got that one, and then again, there's several more. Another one, migrating from Oracle to Postgres. A couple of them, actually. Got lots of presentations. Lots of migrations. It's great to see. We want your data in Postgres. This is how you do it. Okay, so we're going to touch base on some of the global level objects and aspects. Again, these are the things that exist throughout the entire cluster, and we will we'll go into those now. Clusters, right? A cluster, a lot of times cluster refers to a group of machines. For Postgres, it's a group of databases, right? So if we think of this laptop as the server, within that server, you can have different clusters of databases. So you can have your Postgres 14 set up, Postgres 17, and then Postgres 9.6 for the legacy, right? It's just a collection of databases. So each of these clusters has its own databases, table spaces, roles, and configurations. Yep. So that's the clusters, and we know what the database is, right? As a separate environment within the cluster that has its own set of schemas, tables, indexes, sequences, extensions, all that fun stuff. So what are table spaces? Table spaces are the actual physical location of the data files. Welcome, come on in. That's the actual physical location, and it can be associated with multiple databases. It can span across them. It is great for separating disk space for performance specifically, right? So if you have your working data and you want that on your fast disk, then you can set that over there. And if you have archive data, you can set that to the slow disk. And there's lots of other fun stuff you can do with that as well. Okay, so the roles, these are the users and or groups with specific permissions. You can control access to database objects very specifically, as well as specify authentication configuration for those roles. You can also configure very specific settings, like log statement 0, for example, for a role will log everything that role does, not just anything that passed a certain threshold. So if you're interested in more on roles and users, there is a presentation on row-level security here. All right, so now let's touch base on languages. These are, it's mainly SQL, but there are other procedural languages for writing functions and procedures. And there's PGSQL, which is for the control structures, loops, and exception handling. And you can also use Python, Perl. There are a bunch of other ones as well. These are the ones I've included. But SQL is the core language, as we know. And if you are interested in other presentations that focus on fine-tuning SQL, here are these. One's today and one's tomorrow. Okay, and now let's talk about physical replication. So physical replication replicates the actual data files in the database. So it moves it from one location to another location, but it's going to be the entire cluster. And this streams the database changes via the wall logs, which we will touch base on at the end. Those are the write-ahead logs. And then if you want to have a server in hot standby mode, so you can do read queries, and it's available using those by applying those walls, you can do that with physical replication. This is very good for the high availability and disaster recovery setups, and also very good for horizontal scaling for read trafficking and just very large data sets. Okay, and these presentations are not just for physical replication, but I included all for replication. And this is both physical and logical replication. And we'll go over logical replication here in a second. But again, we have lots of presentations on migrations and replication today and tomorrow. And I will upload these slides after we are done today, so they'll be available for you via the website. Okay, so again, talking about these global settings, configuration is configured at a global level. And this mainly happens in PostgreSQL conf, but you can alter settings in PSQL with alter system set command, which will add whatever the setting was to the Postgres auto conf file. And this will get loaded after PostgreSQL conf gets loaded. So it'll load all those configurations, and then it'll load PostgreSQL autoconf, and that'll override anything in PostgreSQL conf that doesn't match. And then you can specify your authentication settings in PGHBA conf. And these can, like a lot of these settings are customizable at so many different levels. I include them at the global level because it really just spans downward. And if you are interested in more aspects of the global level that we probably didn't touch on today, there are these presentations that can give you some more information. Okay, so let's take a moment to answer any questions anyone might have about the global level on Postgres. Okay, we'll move right along then. To the database level. So all of the objects and aspects we're talking about here exist within a database and across all the aspects in there, all the objects in there for the most part. So schemas are the main one, right? So these are logical containers within a database that help organize objects. It provides a namespace so you can put things in a place and label it in a way that you understand. There's, of course, the public schema, which is the default schema, but you can also create like an archive one, and if you combine that with what we were talking about earlier with table spaces, you can put the archive schema essentially on a slow disk so that it can retrieve information, but it doesn't have to be super quick. And you can also create queries that work across schemas, but not queries that work across databases or clusters. And one of the amazing things about Postgres is its ability to extend. These extensions are additional modules that enhance PostgreSQL functionality. There's several examples here. There are so many, but the beauty of this too is you get to create your own extensions if you want to. If it doesn't function how you want to, you can make it. If you're interested in more information, here are the presentations on extensions for today and tomorrow. And these ones right here are all for today. And I believe this is the rest of them. Again, several presentations about extensions because it's an amazing feature for Postgres, allowing for great functionality. Speaking of functionality, we got functions. Functions are reusable blocks of codes, pretty common concept, but it can intake parameter values, execute operations, and then have a return value. It is a great way to reuse logic and can also be used for SQL queries. So there are lots of ways to use functions. There are also procedures, which are essentially functions that don't have a return value. And these can have multiple transactions, which can be beneficial depending on your use case. Okay, data types in Postgres, they're all the common ones, or not all the common ones, right, but a lot of the common ones. We have your int, your big int, your character, those fun ones, but it also comes with a wide variety of other data types, such as phone number, zip code, vector, point, and you can also, of course, create your own data types if you want. If you're interested in more information on, it looks like the vector data type, there's a presentation for that. Okay, so we touched base on physical replication. Now we're going to talk about logical replication, and this is, again, at the database level instead of the global level. So logical replication is different than physical replication in that it operates at a higher level, so you can target specific tables, subsets of table, or data sets. With logical replication, there is a publication subscription setup. So the publication will logically it will encrypt it'll code the messages, the WAL files rather, and then it will send those over to the subscriber, and the subscriber will unpack those, it will extract those, and then apply those changes from those WAL files to the subscriber database. Again, these are we already showed you these, but in case you were wondering, there are, again, logical replication ones and physical replications in here, but I'll just go ahead and breeze through this. But I put it on here twice because some of these were a little I'm not quite sure what they use. I would have to go to the presentation to know, so I wanted to make sure they were included as well.
Can you go briefly over to logical and physical replication?
Yeah. Physical replication occurs at the block level. It is copying the entire data files, right? Logical replication, you can fine tune it to just do one table. You can do certain columns in a table. You can fine tune it very finely, where it's not just everything, right? There are lots of options for this to explore. Cool. And again, it has a publication subscription setup, so it's like you have to set up a publication, and then in that you can specify what you want to send over. Okay. Now, an interesting thing about logical replication too is that if you apply schema changes to the publisher, those have to be applied on the subscriber as well. In fact, with the way that we do it at Command Prompt is we try to apply the changes on the subscriber first, so that when you put them on the publisher, it's ready to go. Because if you have it, yeah. So if you change the schema on the publisher, and then it will error when it's sending, because there's something different on the subscriber. Now the subscriber can be a little bit different. That table structure can be a little bit different, as long as it includes what's being published over here on the publisher. Okay. Yes, sir.
Elaborate a little bit on that answer.
Please.
So logical replication, at least in Postgres, is decoding the physical wall logs into another format that could be applied somewhere else. So the native logical replication of Postgres converts the physical block stream into insert, update, delete statements to get applied on the other side.
Okay, right.
There are other logical decoders behind that you could convert that physical stream into, say, JSON. And then you could put it into a queue like Kafka and be able to apply it somewhere else and push that into, some sort of other storage device or something completely unrelated to Postgres. So the logical is taking that physical representation and turning it into usually a more human readable format, but making it so this way you're not tied to the specific major version of Postgres as you're applying it somewhere else. So like the logical replication allows you to do major version upgrades across versions of Postgres, and not have to have the exact same version that you do for physical.
But like you just said, you can use it outside of their database.
Yes, like if you want to replicate from Postgres to SQL Server.
So essentially it's an export, is really what it is.
Well, it's a change data capture stream of everything that's going on. You initially sync it up with an export, but it's all the change logs essentially as it's going across as insert, update, delete statements.
Wonderful details. Thank you, Jimmy. Yeah. So yeah, very versatile, right? Yeah. Okay, cool. So again, here are the other talks with that. All right, and so those are the main things I was covering for the database level. So here are some other talks about essentially collation challenges, it looks like, at the database level. But before we move on to the schema level, do we have any questions about the database level? Cool. All right, so the schema level, again, all the objects in here are going to be within the same schema. So it's underneath the database. There can be different ones within the database, but within the schema, these, if you set these in here, then they will be throughout the schema. And the first and major one, of course, is tables. We know what tables are, made up of rows and columns. There are several different kinds of tables, though, in Postgres. We have your partition tables, inheritance tables, your foreign tables, toast tables. Temporary and unlogged, I'm not going to cover in this presentation. Temporary ones are temporary. They go away. The unlogged ones are, speaking of the wall files, right? The wall files do not capture the changes in here. So if there's a server reset or something, those will not be applied. And that's essentially what unlogged tables, that's their altered mechanism. Okay, so partition tables are essentially tables that have been divided down into smaller partitions. And they together, when they're added up, make the full table, right? So this can make large amounts of data way more manageable, and they can be used to simplify the archiving process, right? So if you archive older data, you can make a partition that contains all of that data from certain date. or to a certain date rather, from and to a certain date. And then you can, at a certain point, you can detach that partition and you can archive it and then you can drop it. There are also inheritance tables, and these essentially inherit the structure property of another table, right? Which is similar to what partition tables do. In fact, this is the old method for partitioning, but it is not recommended anymore. If you're interested in learning more about partitioning, please check out this talk. All right. Now let's discuss foreign tables. Foreign tables are fun. They reference data stored in another database or external source. And they use a foreign data wrapper extension. And that is how you are able to retrieve that data. So I did not put this in the extension, but do know that there is a foreign data wrapper extension, please, that can help with your structuring. Okay, toast tables. The oversized attribute storage technique, TOAST, it allows for efficient storage of large data values that exceed a certain size, which is usually 2 kilobytes. And essentially what happens is that if your data in a column goes over the allotted size, again, 2 kilobytes, for example, then what it does is it compresses the data down and it sends it to the toast table for storage. And then it will, when you query the table, it will go retrieve that data and uncompact it to present it. And Postgres does this transparently. You don't need to do anything. It knows how to do this itself. So sequences are the objects that generate unique numeric identifiers. And these are primarily used for primary keys. And it is important to note that these are not necessarily sequential, right? So it does like to go 1, 2, 3, but there can be gaps in the data or in the sequences, right? It's not always sequential. And this can happen a lot of times for like if you're migrating data, you're going to want to, using logical replication, you're going to want to jump the sequences because weird things can happen if you don't. So it's also important to know that these exist outside of transactions. Okay. And then views. Views are virtual tables that are created from querying one or more tables. They help simplify complex queries. And there are user views as well as system views, same as tables, right? There is also a materialized view, which takes up actual physical storage. So the regular views do not, but the materialized views need to be updated manually. So it is a process sometimes, and it can throw a wrench into certain setups depending on how you operate. All right, triggers. Triggers are functions, right, which we covered earlier, that are called in response to specific table events like inserts, updates, and deletes. And this helps respond to database level events, but they also exist at many different levels throughout the cluster. So perhaps this would have been better in the database or global level. Not sure. Any opinions? Triggers are global? I got that on there. Event triggers respond to database level events, so they are global. Some of them are global. Okay, some like ones that are included in Postgres? Okay, interesting. Cool, so this belongs in the global level then. Yeah, it's kind of, so cluster level?
Some are at the cluster level, some are at the database level, some are at the object level.
Right, it's fun, right? They're everywhere. All right, speaking of everywhere, let's talk about locks now. Postgres must use locks in order to perform certain operations while maintaining the ACID compliance, so making sure your data has integrity and consistency. These are managed automatically by Postgres, but you can also acquire and release locks manually. So we'll cover row-level locks, table-level locks, and advisory locks real quick. So row-level locks are applied to individual rows and multiple transactions, and they operate on different rows of the same table simultaneously. So deadlocks can occur if two transactions hold locks on different rows, and each one of them is waiting for the other one to release their lock. In this case, PostgreSQL will abort one. I'm not sure exactly how it determines that, but I think that's fascinating to me. Do what? What, cage match? Yeah, absolutely, absolutely. Winner takes all. Yeah. Bad data will be deleted. Yeah, yeah, absolutely. And so here's a table. This is straight from the Postgres docs, letting you know where the conflicts are, right? So for update has a conflict with all of them on here, but for key share would only have a conflict with the for update lock.
So what's the difference between the key share and
To be
you're talking about the primary key on a table? Is that what you're?
Yeah, so I will be frank with you. I'm not very experienced with a lot of the details in this. Some of these locks come up very infrequently, and also the row level locks here are not ones that you typically have to manage manually. They are, again, if there's a conflict, PostgreSQL will start a cage match and get rid of one, and one will be declared the victor, and then one of them is happy and one of them is not. But the beauty is that after the other one performs whatever operation it needs to do, then the other one gets its turn. Okay.
I can add one thing.
Yes, please, please. If you have more information, please.
Maybe in the slide with SQL Server background, then unlike SQL Server, Postgres won't block readers with writers. So you don't see that block because of the MVCC information. But here, if two users are trying to update or trying to delete, trying to modify one record, they only use the blocking in Postgres. So it is as a, similar to SQL Server, if you compare, it's like snapshot level isolation. That's what the Postgres is. That's what the Postgres is.
Very cool.
But in Postgres, we see less deadlocks because of the MVCC nature.
Right, and I got it. I mean, that's like the minutia that most people aren't gonna run into.
Yeah, right. So yeah, it is very much the minutia, but
It's just the concept of blocks and deadlocks. I mean, no, I understand that.
yeah. And again, this one, Postgres handles like automatically. So you would, again, in my work, I don't confront these often. So I don't know a lot of the details around them, but I wanted to present them as information that is important to understand, certainly a feature of Postgres. Okay. Well, thank you for your question, and thank you for your additional details. Okay, and so then we have table level locks, right? So many more of these, many more potential conflicts, and these ones are a bit more aggressive. So these affect the entire table and can prevent certain operations while being held. So like the access exclusive lock, when that's on a table, you cannot use that table, right? It conflicts with everything. An access share lock, though, will share access, and it only conflicts with the access exclusive one where it takes the entire table, right? And everything in between. And I do love this table, if I can for a second, just point out my favorite part of it. The share one shares, right? It shares with share. That it like does not conflict with itself. And I find that pretty awesome. Okay, so let's talk about advisory locks real quick. These are user defined, and they are usually used for applications so that you can perform some session level or some transaction level locks if you'd like. The session level ones are held till the end of the session. These are good for long running queries. The transaction level ones release at the end of a transaction, obviously, and they are good for short-lived locks. And again, we've touched base on the deadlock detection, right? If there are these row level locks, then one of them will wait for the other one, and Postgres will declare a cage match, and Dana White will come raise the hand of the victor, and that one gets to go first. But the other one still gets to go, so we're still sharing. All right, and then there are also lock waits. So when a transaction requests a lock that's held by another transaction, it will wait. It's very patient like that. That you can also configure an optional timeout for this if it's taking too long and you need to perform other things. The There's also a way to monitor these in PG locks as well as PG stat activity. You can query for these and find information on these locks. All right, so that was everything at the schema level. Are there any questions about schema level events that we didn't already touch base on? Okay, beautiful. Let's keep rolling then. All right, so now we're at the table level.
And this is just more of a general question. So I'm totally new to Postgres. But,
Yeah.
do you have any book recommendations, or the audience have any good book recommendations?
I will let the audience, if you all have any ideas on places to start for somebody. And what's your background? Where are you coming from?
Oracle and SQL Server.
Oracle SQL Server.
Ingress, which only the really old people probably know.
Yeah, there are a lot of books, but there is one book I can recommend.
And if you'd be interested in writing it down for him, do that real quick.
Sure, because there is a book called Postgres for SQL Server DBAs. So using your
Right.
Beautiful. All right, cool. Good question. Thank you.
This website, I can write it down after him. Okay, great. Enter DB.
Ah, cool. All right, thank you all. Okay, so we're talking about constraints now, and these help maintain the data integrity and ensure that the data adheres to specific rules. So it's important to note that while these are good, too many of them can really actually hinder performance on your database. So balance is what you're going to want to seek with these if you have a lot of rules that need to be applied, or constraints rather that need to be applied. So going back real quick, we're going to touch on these: primary key, foreign key, the unique constraints, check, not null, and exclusion constraints. So the primary key constraints, as most of us probably know, you have like primary keys. There can only be one on a table, and it helps uniquely identify rows. They must contain values. They may not be null, but you can compose a primary key out of multiple columns in a table, so it doesn't have to just be the one. Foreign key constraints create a link between one table and the column in another table, and it's often the primary key, but does not have to be. And this is the backbone of a relational database. This is what tells everything that it relates to one another, and that the data is what we think it is. And it's in preparing this, it helped me realize what a vital aspect this is for the relational database, and like it's really the foundational key to it. It, of course, helps ensure referential integrity. You can have multiple foreign keys, right? Again, these do get, there can be issues with these when it comes to deleting records, but you can use cascade delete, which will delete the record that it references from the table. Now, you want to be very careful with this. Don't use it lightly, because it's very, things go wrong with this sometimes, often. And so you have to be very mindful of what you are deleting if you use to cascade delete, so that it does not delete records that you do need in other tables. All right, so now we also have our unique constraints. These ensure that all non-null values in a column or a set of columns are unique. Okay, this is often used for like logical replication of if there's not a primary key on a table, you can create a unique constraint and make sure that the data is transferred and replicated. Unlike primary keys, though, null values are allowed with unique constraints, so it can be beneficial for certain tables, and it can also have multiple unique constraints. All right, check constraint enforces a specific condition for a column's values or multiple columns values. So they check whether or not that data meets the condition, and if it does, it'll let it in. If it doesn't, it won't. Pretty simple. And again, there can be multiple of these in a table, and they should not reference data from other rows, which was another fun thing that I learned in creating this presentation. Lots of fun conflicts come up there. Not null constraints. These are essentially check constraints, but they check to make sure that the data is not null. Exclusion constraints. These ensure that a specific column does not have duplicate values when using a specific operator. Often used with geometric types or ranges. I do not come across these often. Do any of you come across these very often? Ahaha. All the time, huh? Yeah, fun stuff, I'm sure.
It's usually around timestamps.
Oh,
Have overlapping schedules with timestamps, so it's a great way of saying you don't want to book a room or whatever.
yeah.
It's not necessarily duplicate values, it's overlapping values.
Okay, interesting.
Inclusion of ranges.
Right. So like the same date around the same time or something.
You can't book this room at the same time for 2 different sections.
Yeah, makes perfect sense.
Yeah, exactly.
And that's what I was just gonna ask, is there like geography data types too, is that?
Yeah.
Yep.
Same sort of thing, like if you had 2 people in the same room, you would keep track of the fact that they had the same.
I don't think any of the other databases have that built in, it's just a constraint like that at the table.
Yeah, it would've been handy, I was on a contract, but it was working with ex-cons and ankle bracelets, and so I had to actually deal with that if they and their buddies were together in the same room, then they would have the same, locator.
Oh.
And the same timestamp, and so then it became a little more complicated to keep track of.
Yeah.
This is the amount of code you need significantly.
Interesting.
Yeah, fantastic. Thank you for that additional information. Oh, another cool thing is that it automatically creates an index to use. Who knew? Jimmy knew. All right, so indexes. Speaking of indexes, this is an object that organizes column values so they're more quickly retrieved. There are lots of different types of indexes. The most common one is the B tree, right? It's the default. It's good for most use cases. There are, of course, other ones, but I'm going to leave that for a different presentation. But speaking of that presentation, there's this presentation if you're interested in more information on indexes. And that's today at 4:30 in this room. Okay. Vacuums. This is an operation that helps remove dead tuples from tables. Tuples are rows, right? It's just another fun word for rows. I have a coworker that calls them tulips, which is very pretty, I think. It helps reclaim that space. Auto vacuum is a type of vacuum that runs automatically based on thresholds, and you can adjust those for specific tables or databases. And vacuum full is an important vacuum to understand. Vacuum full actually basically just rewrites the table in the physical disk location, right? So in doing that, what it does, instead of just reclaiming space for the table, which is what vacuum does and auto vacuum does, it actually reclaims the disk space so that you can use that wherever. Yes, lots of times though, vacuum full, there is an extension called PG Repack, which does it with less locks and less constraints. Vacuum full is a very intensive operation, and a lot of the times you have to take a little downtime in order to rewrite this entire table.
So technically it could be online, but most.
Yeah,
Practically, you shouldn't.
it depends on your table, but if your table needs a vacuum full, it's probably not going to be online. Right? It's probably going to be a big, there you go. Okay. Yeah, but depending on the size of the table will determine how long it has it, right? Yeah. But again, basically what Jimmy's saying is if it needs it, it's big enough that that you're gonna need to take a little downtime. But again, the extension PG Repack can help do that online. So that's pretty cool. And then there's vacuum analyze also, which will analyze the table and set the query stats while vacuum as well. Okay, so rules and table settings. Rules are features that allow the definition of certain SQL commands and how they behave when applied to a table. This can rewrite queries automatically, which is pretty cool. So database changes, the application changes are not necessarily needed, depending on what the rule is. Some table settings can be modified on a per table basis. Again, this is a great feature where Postgres is very customizable. You can modify the compression of a table, the vacuum settings, auto vacuum settings as well, the fill factor, how much of a data page it uses before going to the next one. There are lots of settings. So those are the table level. That's the table level aspects. Do we have any questions on those that we didn't cover? Okay, cool. Moving right along then. All right, so we'll just touch base. Okay, thank you for coming, Michael. Touch base on some internal processes real quick. We have our background writer, which writes dirty pages to disk. And dirty pages, help me if I stumble on this, please, Jimmy. Dirty pages are essentially, they are changes that have been made to the database, but that has not been written to disk yet. Okay, so the background writer writes that to disk, gets rid of those dirty pages. There's a checkpointer, so that is, if I'm correct, that right there is a checkpoint when it writes it to disk. Is that correct? Okay, please help specify what the checkpoint is, if you would. I'm so glad you came today.
They're very related. Checkpoint, so a checkpoint happens whenever a certain threshold reaches or you filled up someone's wall log. So it's flushing all the changes that's in the wall log.
Okay. So the background writer writes it to the wall log writes it, right, and then those changes get applied to disk.
There's other things that make changes to the pages that aren't necessarily wall log.
Okay. Okay.
Right? So things like the background writer does is when it has to free up a buffer and a shared buffer to the new buffer, the background writer fix that, and if it's dirty, it has to flush it out.
Okay, that's right. Thank you. Thank you for the clarification, sir. And then we have our statistics collector here, which gathers stats about database activity. It's very well named. Unfortunately, this was discontinued in PostgreSQL 15, so it's only in 14 before, but it's still an important feature. Then you have your auto vacuum launcher, which again launches the auto vacuum based on certain thresholds. We have our system logs. So we'll just go over this briefly. There are logs that get generated about all the changes in there. Some of the most important ones are probably the error, right? So these are recorded errors, warnings, and other critical events. But it also can track the queries that are performed. And then it can record connection information, connects, disconnects, attempted connects. And then checkpoints. When the checkpoints occur, it'll record details about that. And lots of these settings can be configured, again, in PostgreSQL conf. And then we have our wall. So I told you we'd get to it, and we got to it eventually. We've been talking about it this whole time, and I bet you're wondering what it is if you don't already know. They are the write-ahead logging files. And these record the changes made to the database. And again, these are very important they're very important for physical replication as well as logical replication. But they ensure data integrity and durability for recovery in a crash. And they are when the wall files are written to disk, which is what we were just talking about, a checkpoint is created, helping to manage their size. And it's great for it's critical for point-in-time recovery as well. And it can also help facilitate archiving wall file, or PostgreSQL will archive the wall files that it does not need anymore. So if it doesn't need it, if it's used it, if it's sent the information, then it doesn't need it for anything else, it knows that and it gets rid of it. And if you are interested in more information on any internals, these will cover things that I did not cover, most likely. We got a few today and a couple tomorrow. And these are some other cool aspects that didn't quite fit into the other categories. So Aaron will be doing a SEAL Team 6 presentation about leadership, which is an amazing presentation. I've seen it before. If you're interested in that, which it's fantastic. Thank you, kind sir. All right. That being said, there are a couple other ones. Someone has used Postgres to customize the Wordle game, which is fascinating. And there's a couple of Kubernetes stuff going on in here too. Okay. So again, Postgres is an amazing database management system. It's huge. It's got, it's ever evolving, got lots of capabilities. We've reviewed things at the global level, database level, schema level, and table level. That hopefully we've provided like a framework of these puzzle pieces, because the puzzle itself, I have no clue what it looks like. It's different for everybody, right? And so hopefully some of these other presentations can give you some guidance if you need certain details or aspects covered. Hopefully some of these other presentations today and tomorrow can help fill in the rest of these gaps. Yeah, it's complicated and messy. If you need support, that's what we do at Command Prompt, right? We do Postgres. I have a team full of experts that are far more knowledgeable than I am, and they have passed on that knowledge to me. I feel very fortunate to work with them, also a great group of people. I would like to thank Jimmy. Thank you so much for being here and for helping fill in these details that, again, helped me learn as well. We have an education blog at commandprompt.com/education. Please check that out. We also have, I also have some business cards if you're interested in that. I'm super excited. Got business cards. Anyway, that's all I have for today. Do you all have any questions? These are all the presentations that I can just let go if you want to look at them. But other than that, that's all I have for you. Thank you. I appreciate y'all. I don't even know how to put this on like a scroll. But yeah, we got lots of presentations today and tomorrow. Lots of good stuff here. But anyway, I will get this posted onto the website. I'll get it uploaded so that if you're interested, you can go grab that, and then you can have this information as well as these meetings. And hopefully, I like to think it organized it in a way that was applicable and helpful. Cool. Yes, bud.
In one of the slides, it says that the statistics collector is expected to.
Yes.
Which statistics collector?
Uses that. Yeah.
It got rolled into shared memory, so the stats collector used to have to write it out to disk all the time. Now it's just in memory all the time, so it doesn't have to have a separate background.
Yeah. But like PG stat statements will help. Is an extension that also like collects stats as well, right?
Yeah, that's for stuff like PG stat all tables.
Yeah. Gotcha. That's just in memory now, huh? Oh, interesting.
You used to have to put it like on a RAM disk.
Right. Huh.
What are the pros and cons? Is there any reason behind why?
In memory? Yeah, because it was a performance bottleneck.
Oh,
So under very heavy loads, you would always have to keep flushing it out the disk. That would sit.
so that means if someone restarts that database, then it's gone.
If it crashes, it goes away.
Oh,
Right, so it periodically flushes it out the disk to persist it, but it's not part of the main stats collecting process. It's in the background, it got rolled into, I think, the background workload that'll periodically just does it. Or if you do a clean shutdown, it flushes it out.
Thank you all so much for coming. I really appreciate y'all being here. Thank you.